Hi students, and welcome to today's lesson. I'm Mrs. Baidani. Today we will explore the question, how do stars appear to move across the sky? Are you ready? Grab your pencil and your science journal, and let's get started. Imagine it's a starry night and we're outside looking at the stars. Can you spot the brightest star in the night sky? Go ahead and point to the star on your screen. The brightest star is here, just above the trees. That star is Sirius, the brightest star we can see from Earth at nighttime anyway. Let's watch a video clip of this night sky. What do you observe about the stars in the video clip? I noticed that the stars appear to move together from left to right across the sky. Do you notice that too? Let's watch the video clip again. This time, let's try to track the motion of Sirius. Ready? How does Sirius appear to move across the night sky? Sirius appears to move from left to right and drop toward the horizon. I wonder why Sirius appears to move this way. What are your initial ideas about why Sirius appears to move? Do you wonder if this apparent motion is because of Earth's rotation? What other questions do you have about the motion of stars? Maybe you wonder, do the stars move through the sky in the same direction as the sun and the moon? Or maybe you want to know, can we see different stars from different places on Earth? Let's try to answer some of these questions as we explore the question, how do stars appear to move across the sky? I wonder, how can we use what we already know to explain how Sirius appears to move? Well, what have we already observed about the apparent motion of objects in space? We have observed that the sun appears to move from east to west in the sky. We also observed that the moon appears to move from east to west in the sky. Could the same be true about stars? Let's also look at the sun and moon sections of our anchor chart to see what else we've learned about the apparent motion of objects. We wrote that the sun and the moon appear to move throughout a day because Earth rotates. Could the same be true for stars? Let's visit our virtual students again to see if they can help. What changes should be made to our Earth View student model to investigate the apparent motion of stars at night? We want to see what the stars look like from the perspective of Earth. Do we need the sun? I think so. The location of the sun shows us which side of Earth is in daytime and which is in nighttime. What do we need to add? Oh, right! We need stars. We've added stars to the wall of our classroom. Now stars are all around Earth, but for this model, we put them only on the nighttime side of Earth, which we know is the opposite side from where the sun is. Based on what we already learned about the apparent motion of the moon and the sun, what should our Earth student do in the model to show the apparent motion of the stars? Did you say rotate? Great idea! Let's watch as our Earth student rotates. So, how does this model explain the apparent motion of stars in the night sky? As the Earth student rotates counterclockwise, she begins to see the stars right after sunset. As she continues to rotate, the Earth student can see the stars on the wall rise and set. Based on our model, what prediction can you make about the direction of the star's apparent motion? Well, if stars' apparent motion is caused by Earth's rotation, then they should move from east to west across the sky, just like the sun and the moon, right? I agree. Great work! Let's see if our model is accurate. Here's a video clip that shows the movement of celestial objects, including the sun, the moon, and stars. Let's watch. What patterns do you notice about the motion of celestial objects in this video clip? Do you notice the sun setting and then the moon setting over the mountains? So do I. I also noticed that all the celestial objects, the sun, the moon, and stars, moved in the same direction across the sky. So, what evidence does this video clip provide about the apparent motion of stars? Answering this question is one of your tasks for today. The video shows the direction the stars are moving. How does this compare to the apparent motion of the moon and sun? Wow, we have learned a lot about stars today. One of your tasks for today will be to summarize what you learned. Let's look at one more video clip. Look closely at the way the stars move in the sky. Wow, the stars seem to move differently in this video clip than they did in the video clip we watched at the beginning of the lesson. Did you notice a difference? How does the apparent motion of stars in this video clip compare with the apparent motion of Sirius in the previous video clips? Do you notice that the stars in this video clip seem to circle around the center star, while the stars move from left to right in the other video clip? I noticed the same thing. We definitely see a difference in patterns of motion between the two video clips we watched. What do you think could explain these different patterns of motion? Maybe the video clips were taken from different locations on Earth. Or maybe the camera was pointed toward different parts of the sky. We have more exploring to do. In our next lesson, we'll keep investigating the apparent motion of stars. Let's review your tasks for today. First, answer the questions about the video clip. Second, summarize what you learned about stars in this lesson.